Hey there, fifth hour. We are going to have our video today for 11.1, area of parallelograms and triangles. We did this for 2 days in class, or over 2 days in class, but we'll just see if we can get it through in one video. All right, so let's start off here. We have the area of a parallelogram. Well, in a parallelogram, we have, notice how I have this line drop down here. It makes a right angle, and this is the height of our parallelogram. Sometimes you'll see the height done outside of the parallelogram, but it's still making that right angle. All right, and then we have our base. And the base on the bottom and the top are going to be congruent. So our area formula is base times the height. So let's go right into our problems here. We're going to ask for both the perimeter and the area of each parallelogram. So if we start off here with perimeter, like I said before, the bases are going to be the same all around. So go ahead and add up all 4 of those sides. I'll wait for you. All right, so if we go ahead and do that, we get 56. Don't forget a label of meters. Now we come to our area. Remember, our area formula is base times height. So our base was the 16, and our height is that 10 now that we're going to use. So if we multiply those, we get an area of 160 meters squared. Labels are very important in when we're doing anything like this with perimeter and area, and when we get to surface area and volume with 3D solids, we're going to want those labels there too. All right, let's look at this next problem here. Again, we're going to ask for perimeter and our area. So I'm going to take this 10 and bring it over to the other side. And I see I have 4 there. So 4 plus 10 gives us 14, plus another 4 and 10. We have a perimeter of 28 inches. Then we're going to find our area. So base times height. Now our height this time was tucked inside of that parallelogram, kind of slanted. And when we talk about base, we're going to talk about this 10. Now I know the 10 is not the one that's on the bottom per se of this parallelogram, but our height is coming from that same direction. It's 90 degrees to that base there. So we're going to take our 5 times our 10, and we get an area of 50 inches squared. Now this next one's going to be a little bit different. Find the perimeter. Well, if we look, we have our 23 feet on the bottom. We have a 23 feet on the, so we can put a 23 feet on the top, but we don't have this slant height right here. So if you look, they do give us some information outside of our parallelogram. And if we notice, it's a nice right triangle. And the one thing we love to do with right triangles, that's right, is to do Pythagorean theorem. So our slant height there is going to be, we're going to just call it x, and it's right across from that 90-degree angle. So that is going to be our hypotenuse. And so we are going to take 24 squared and add it to 7 squared, and we get x squared. Go ahead and pause the video, get that figured out, find out what x equals. All right, our x equaled 25. So I'm going to change that. I'm going to erase that x here and put a 25 there and a 25 here. So let's go ahead. 25 plus 25 gives us 50, plus a 23 gives us 73, plus another 23 gives us 96, what's our label here, feet. Looking for our area. Now we know our, well, let's see here. Our base, is that going to be the 23 or the 7, or should we add them? Well, we're going to talk about our parallelogram here, so this dark shaded area. So we're just looking that base there, so our 23. Times our height. Now remember, the height is the one that drops down and makes a 90-degree angle with our base, so we're going to use that 24. Go ahead, and that gets us 552 feet squared for our area. All right, I'm going to leave this one here for you guys to try out. Find the perimeter and the area of our parallelogram. Notice here that we are missing our height inside of the parallelogram. All right, turn it on over once you're done with that, and join me to do triangles. Triangles, again, we have a height drop down, and it meets a 90-degree angle with our base. So we're going to call that height and base. All right, again, just like in parallelograms, sometimes the height is dropped down outside of our triangle, so just keep that in mind. All right, well, I learned area formula for a triangle is 1/2 base times height. It's half of a rectangle, and so that's just like a parallelogram, so we just take half of that. A lot of kids are nowadays learning as base times height, divide by 2. Divide by 2 or timesing by 1/2, both get us to the same point. So either one of those formulas is going to work for us. All right, so find the perimeter and area of each triangle. Well, to do the perimeter, we got to add up all the stuff on the around the edge of the triangle. Again, we're looking at the shaded one, and I see that we're missing that one right there. But we are lucky enough to have a right triangle formed right outside, so we can do our Pythagorean theorem again. So 27 squared plus 30 squared equals x squared. X again is our hypotenuse because it's across from that 90-degree angle. If we are to type that into our calculator, let's just round it to 1 decimal place and get 40.4. So I'm going to erase my x and put in a 40.4 now. All right, now I can go up and add up all those sides. 40.4 plus 19 plus 41. Remember, we're only adding the ones around the dark shaded area. And we get 100.4 inches for our perimeter. Now with our triangle, our base is going to be that 19. Again, base doesn't always mean it's on the bottom. We're just looking for the one that has the right angle next to it. So 19 times the height. So again, our height comes from that 90-degree, and then we divide it by 2. So we're going to end up with an area of 285 inches squared. Oops, skipped a problem there. Find the perimeter and area of each parallelogram. I just want to get you guys started on this problem so you can finish it for us. If we look here, perimeter, we're missing 2 sides of our triangle. We're missing both this side here, and we're missing our hypotenuse in our large triangle. So first thing we're going to start with is we're going to start by finding the height of that triangle and do a Pythagorean theorem here. Once you've done that Pythagorean theorem and you have this height here, if you do Pythagorean theorem again, now this time we're going to do it with the big blue triangle, and that's going to find you your hypotenuse. That'll help you find your perimeter, and then you'll find your area from there. All right, word problem. I know we love these. You need to buy enough boards to make a frame of a triangular sandbox shown and enough sand to fill it. If one box or one board is 3 feet long and one bag of sand fills 9 square feet of the sandbox, how many boards and bags do you need to buy? Well, we're talking about 2 different things here. We are talking about the frame, which is reminding me of perimeter. Okay, and then sand to fill it. And this makes me think of area. So I can see that I have all my sides, so I can find my perimeter. So if I find my perimeter, I'm going to take 12 plus 16 plus my 7.5, and we find a perimeter of 35.5 feet. But it didn't ask us what the perimeter it asked. It asked how many boards it's going to take. So if their boards each equal 3 feet long, and we need to cover 35.5 feet, we are going to actually take the 35.5 feet and divide it by 3. This is going to tell us how many boards we need. We're going to need 11.8 boards. Can I buy 0.8 of a board? No. So we need to round that up to 12 boards. All right, so we have half our problem figured out here. Now we need to figure out how many bags of sand we need to fill it, so area. So remember, our area formula for a triangle is that base times height. Base times height, base times height. All right, base we're going to call 12, and our height is going to be 9. Because remember, height is where it makes that 90-degree angle with the base. Don't forget to divide it by 2. So our area ends up being 54. But I'm not going to need 54 bags because each bag fills 9 square feet. Ooh, area is feet squared. So keep that in mind. If I take 54 feet squared and divide it by 9 feet squared, we're going to find out that we need 6 bags. All right. If we take a look here at our next one, ooh, this one we're having a little backwards thinking. This time they give us the area and we need to find our height. So area formula for a parallelogram is base times height. So let's fill in what we know. The area is 148. Our base is 8 and our height is x. So go ahead and solve that. Want to get x by itself. So we're going to divide each side by 8. And we find out that our x is 18.5 meters. All right, number 5, this one, go ahead and try this one on your own. It's the same concept, except for this time we're going to use our area of a triangle formula, base times height, divide by 2. All right, thanks for watching, guys.